Hi everyone. So this will be the last video for the reaction of phenols, and in this video we'll be discussing some miscellaneous reactions which are we can say less important, somewhat less important than the reactions we already discussed about. So we're first of all we're taking the reaction of phenols with zinc dust. This is actually a reduction reaction. Okay, here reduction of phenol takes place in the presence of zinc, and the mixture is heated and we get benzene in this case. Okay, this is the product of the reaction. So and also we get zano zinc oxide in this reaction. So phenols when reacted with zinc dust, okay, this is done at a high temperature, at good temperature, means it's heated. Okay, the mixture is heated, so we get benzene as a product in this reaction. So this is just simple reduction reaction that is taking place in this case. Okay, or we can say redox reaction it is. Again, we can also do the oxidation reaction. Again, this is redox, because whenever there is oxidation, it's accompanied by the reduction. It's always redox reaction, reduction and oxidation reaction. So here we have oxidation of phenol is done with the chromic acid. Okay, we have chromic acid. We get the conjugated diketone. Okay, this is a conjugated diketone. We have the conjugation between we can see that there are alternate double bonds, so all these pi electrons are conjugated. Okay, so this is actually diketone. We have two ketonic groups, which this particular compound is called as benzoquinone. Okay, benzoquinone, or we also call it as parabenzoquinone, or simply quinone. Okay, we have different names. Here we have shown 1,4 benzoquinone, or simply quinone we call it as. So we can easily convert the phenol into this diketone. Okay, despite we don't have the hydrogen here. With the hydrogen on this carbon, this is absent. So why? Because we have double bonds. Okay, so there is no hydrogen on this carbon. In spite of this fact, the phenols are easily oxidized with this oxidizing agent. Okay, so we get the benzoquinone. So this benzoquinone is a very important compound. It's involved in many biological processes. Okay, many biological processes it is involved. Okay, for example, we have electron transport systems, there it's involved, and many other biological functions it performs. And also it serves as a precursor for many organic reactions. Okay, it's particularly a proton acceptor. We use it for many organic reactions. Okay, so these are the simple points that we have to remember for these reactions. Next important reaction is the Friedel-Crafts reaction. So in Friedel-Crafts reaction, the phenol is reacted with the alkyl halide in the presence of anhydrous AlCl3. So Friedel-Crafts alkylation reaction takes place. Okay, this is alkylation. Thus it is Friedel-Crafts alkylation reaction. So phenols react with alkyl halides in the presence of anhydrous AlCl3, and we get two different products in this reaction. The phenol is substituted, okay, at para position and at the ortho position. And if we remember, this is called as the cresol. This is cresol. This is paracresol, and this is orthocresol. Okay, uh, we can also name it by the IUPAC nomenclature system. So this will be 1 2 3 4. So this is 4 methyl phenol. Okay, similarly this is 2 methyl phenol. So these are general names and the IUPAC names for these particular compounds. And one thing that we have to remember, this is the important point that we have to remember in this reaction, that the para product is the major product in this reaction. In Friedel-Crafts alkylation of phenols, the para product is the major product. Why? Because at this position the CH3 is far apart from the hydroxyl group, because CH3 is a bulky group. Okay, at the ortho position, it creates the steric problems. Okay, this is a bulky group. We have three hydrogens that are attached to this carbon, so it makes it a lot bulky. So that's why this product is minor product. The ortho product is minor product. Orthocresol is the minor product that's formed in this reaction, and the major one is the paracresol, because there is the two bulky groups are placed far apart in this case. Okay, that's why the para product is the major product. So phenols also undergo the Friedel-Crafts alkylation, in which the alkyl group is substituted to the aromatic ring of the phenol. Okay. Another important reaction is the coupling with diazonium salts. We can couple the phenol with the, this is actually, these such reactions are called as the coupling reactions. Okay, so we are coupling these two compounds. This is the phenol and this is the benzene diazonium salt. Okay, as we have already discussed about the diazonium salts, diazonium compounds are the compounds with general formula Rn triple bond and X. Okay, where this X is a salt, it can be a halogen, particularly it is actually the halogen, and R can be any alkyl or the aryl group. So in this case we have the aryl group, we have this benzene ring that's attached to nitrogen. So this is benzene diazonium salt. So in alkaline medium, in weakly alkaline solution, we mix the two, so the reaction takes place and we get the 4-hydroxybenzene. This is actually a dye. This gives rise to the colored substance which we call as the azo dyes. Okay, as in this case we have 4-hydroxyazobenzene. This is the product of this reaction. Okay, this is the dye, and this is actually the orange in color. This is orange dye. Orange, Orange. So this is orange colored dye. Okay, so in these reactions we get the dyes, the colored substance which we call as the azo dyes. Okay, so the reaction of phenols with benzene diazonium salt in alkaline medium gives us the colored substances which we call as the azo dyes. In this case we have 4-hydroxyazobenzene. Okay, 4-hydroxyazobenzene, and this is the orange colored dye, and also we get the hydrochloric acid as a byproduct in the reaction. So this is an example of coupling reaction. Okay, so another important reaction is the Fries rearrangement. These are all the less important reactions. Some of them give us the products which are not industrially that much capable of use, and many of these reactions which we are now discussing, they are giving us the product in the less quantity. Okay, as we have in the case of Friedel-Crafts alkylation or this Fries rearrangement, here we get the less quantity of the products. So we can see that what happens actually, the phenol is first converted into this product. Okay, the phenol reacts with acid anhydrides in the presence of acid, and we get this substituted product in the reaction. And this particular product, which is called as a phenyl acetate, in this case we have phenyl acetate. We can have also phenyl benzoate if this is the benzene group that's attached with it, this CO group. Okay, C6H5, then we'll name it as a phenyl benzoate. So in this case it is phenyl acetate. So this phenyl acetate is when reacted with anhydrous AlCl3 in the presence of CS2 as solvent, this is a solvent in the reaction. Okay, this is a solvent in the reaction, non-polar solvent. So we get two products in the reaction. One is the ortho substituted product and one is the para substituted product. This is the ortho hydroxyacetophenone. Okay, ortho hydroxy acetophenone, and is the para hydroxyacetophenone. Okay, or we can also call it as 2-hydroxyacetophenone, and this is 4-hydroxyacetophenone. So these two products we get at higher, if we do the reaction at higher temperature, then the ortho product is the major product, and if we do the same reaction at lower temperature, which is about 343 Kelvin, around that, and it's more than 400 Kelvin. Okay, so at higher temperature we get ortho product. So this reaction is thermally controlled reaction. So we get this product, and at lower temperature we get this one. Again here, the stability of this product is because of the, when we increase temperature, then only we can get this product. In the other case we get at the lower temperatures we get the para product. Why? Because same reason is here, that there is bulkiness in this group. Okay, but with the help of higher temperature we can make the ortho product in the majority. Okay, similarly we can have the phenyl benzoate. In that case we get the ortho hydroxy benzophenone and parahydroxybenzophenone as the product. So these are some of the miscellaneous reactions that we have discussed for the phenols. Okay, so this is what we have to discuss about the phenols. So here we conclude the reactions part of the phenol. So in the upcoming lectures we'll be discussing other aspects of phenols.